Assalamualaikum and a very good morning to everyone. My name is Atika Binti Ahmad ZAMRI, 2021652926. So, today I will present to you about sunlight, twilight and evening skies. Without further ado, let's get started. Firstly, sunset. The time of sunset is defined in astronomy as the moment when the upper limb of the sun disappears below the horizon. The colors of sunset result from a phenomenon called scattering, which is the molecules and small particles in the atmosphere change the direction of light rays and causing them to scatter. Why is the sunset red? During the days, blue is scattered more than other colors because it travels as shorter, smaller waves. However, at sunset, light has further to travel through the atmosphere. The shorter wavelength blue light is scattered further as the sunlight passes over a greater distance, and we can see the longer wavelength yellow and red light. The function. Setting of the sun symbolizes many things to a variety of people and cultures. Hence, sunset represents the opportunity to rest after day of work. Secondly, twilight. Twilight, also known as dawn. And there are 3 stages of twilight, which is civil twilight, nautical twilight, and astronomical twilight. All these 3 stages happen twice in 24 hours period between day and night, and they're repeating in reverse order between night and day. As you can see, there are 3 pictures to show the differences of the twilight. First one is civil twilight. Civil twilight occurs when sun is between 6 degrees below the horizon. At this level, the light level is still bright, particularly in western direction. A few of brighter stars can be seen at the east, and we can still see clearly outdoors without artificial lights. The second one is nautical dawn. Nautical dawn is the time when the center of the sun is at 6 to 12 degrees below the horizon. At the moment, sky is much darker. Artificial light is needed to see clearly outdoors, and the brightest stars can be seen. The third one, which is astronomical twilight, is the instant when the center of the sun is at 12 to 18 degrees below the horizon. At this level, the sky is very dark but brighter in westerly direction. Hundreds of stars can be seen. Thirdly, evening skies. Evening skies refer to the nighttime appearance of celestial objects like stars, planets, and the moon, which are visible in a clear sky between sunset and sunrise when the sun is below the horizon. So, why is the night sky dark? As we know, during the day sunlight floods our atmosphere in all directions, with both direct and reflected sunlight coming to us from everywhere we can see. But at night, the sunlight doesn't flood the atmosphere, and so it dark everywhere in the sky that there isn't a point of light. If away from light pollution, sky will appear black. Hence, thousands of stars can be seen and the Milky Way is visible. So, we can conclude that the darker the sky is, the easier we can see all the beautiful creatures at the sky. That's all from me. Thank you.
Okay, thank you Ati. The best explanation about sunset, twilight and evening sky. So we go the next topic, which is the season and precision, which is the presenter is me, FARIEZ AIMAN, and ALIA NAZIRAH. So let's go. Okay, I will present about the summer first, which is the part of the season in our earth. So maybe we didn't know about the summer. So what is summer? Summer is the warmest season of the year, falling between spring and autumn. Temperature over the period different based upon the location on the earth. Regions near the equator are typically warmer than those lying near the poles. This is because due to the curve of the earth, this place receives the most sunlight according to pedagogy in action. The areas around the earth poles also have eyes, which reflect a lot of the sun rays. So, the summer equinox occurs when the sun passes directly above the equator because of the tilt of the earth. When the seasons are based on the earth's position in relation to the sun, it is called astronomical summer. In the northern hemisphere, astronomical summer happens around June 21. So the North Pole is tilted at the greatest angle toward the sun at this time. So maybe we cannot imagine for now the how come the summer is happen. So we go to the next slide. Okay, for this slide I will tell you how summer got happen. So the first one, we must know in the summer we have a summer solstice. So the summer solstice, the official start of summer, it brings the longest day and shortest night of the year for the 88% of Earth people who live in the northern hemisphere. So that we know how come the summer will be happen, because the location have given the longest day and shortest of night. So that will be the part of the location will be summer. So people around the world traditionally observe the change of season with bonfires and festival. So astronomers can calculate an exact moment for the solstice when Earth reaches the point in its orbit where the North Pole is angled closer to the Sun. So the part, the location, the part of the Earth we know closer to the Sun, that's the location will be summer. So that moment will be at 5:44 p.m. Eastern time on June 20 for the year. So from Earth, the Sun will appear farthest, not relative to the star. People living on the Tropic of Cancer, because 23.5 degree north of the equator, we see the Sun pass straight overhead at noon. So the Sun will be direct to the people. So this is was extreme for the tropical country. We go for the next season, which is spring. Okay, spring is the season during which the natural world revives and reinvigorates after the colder winter months. So that we know the spring season is the most people will like it, because that we know many flowers at the spring season, like we know at Japan we have a sakura. So that's the symbolic of spring season, which is the flower at that time. So during spring, dormant plants begin to grow again. New seedlings sprout out of the ground and hibernating animals awake. So that's spring season. So what most people call spring release on the astronomical definition of the word, defined by the angle of Earth tilt toward the Sun. Astronomical spring are released on equinox and solstices. To define it, spring is generally considered the period between the spring equinox and the summer solstice. So equinox are days during the year when day and night are almost equal, which is the same. We have a day and the night the same, almost equal. So there are two equinoxes each calendar year, one in the spring and one in the fall. The spring or vernal equinox occurs around March 20 in the northern hemisphere and around September 22 in southern hemisphere. Okay, so that we know about the spring season.
Assalamualaikum warahmatullahi wabarakatuh. I'm ALIA NAZIRAH binti HAMISHAM from IC22028. So next, I would like to proceed the presentation with the autumn season. So, what is the autumn season? Autumn season is actually the transition of summer to the winter. Now, I would like to share about the characteristic of the autumn season. Firstly, the temperature of this season will drop or decrease. Moreover, the leaf will start to change the color to red, orange, yellow, and brown. Furthermore, at the end of this season, the leaf will start to fall. So, did you guys curious about how this season will happen? Alright, I will explain the process of the autumn season. Firstly, this autumn season will be occur during the equinoxes, which is the position of the Earth is vertically with the Sun. It's also known as autumnal equinoxes. As you can see in the picture, the part of the Earth that close to the Sun will be occur the autumn season, while the other hemisphere of the Earth will be face the spring season. Firstly, for the northern hemisphere, the autumn season usually occur during 22nd to 23rd September. However, at the southern hemisphere, the autumn season will occur in range of 20 to 21st March. Based on this situation, I can conclude that at the moment of the Earth and the Sun is at the equinoxes, the day and the night are equal in length. After finishing all the process of the autumn season, the winter will be occur. At this season, it is the most coolest season compared to the other season in this earth. At the same time, in the winter season, the snow is starting to fall. And in addition, we can see that the daylight is longer than darkness, except at the vernal equinoxes. To understand how the winter season will be occur, okay, this phenomena is actually occur during the vernal equinoxes, which is the position of the Earth is horizontally with the Sun, as you can see in the picture given. In the southern hemisphere, the winter season will be occur during the 21st or 22nd of June until the 22 or 23 September. However, in the northern hemisphere, the winter season will be occur at December, or which is 21st or 22 2nd of December. In the conclusion, at the vernal equinox, the day and the night of the Earth will be equal. However, it is commonly regarded as extending from the winter solstice, so the years is shortened at the day.
Hi, Assalamualaikum and a very good morning to everyone. I am the next presenter. My name is NAZIHAH, and for today I will be presenting about my topic that are moon phases and eclipses. Let's carry on our first subtopic that are the phases of the moon. The moon orbits the Earth about once every month. And we can see that the moon appears to have different phases, and it is because we see more or less of the lighted side of the moon depending on where it is with respect to the sun. As you can see here on the diagram, the moon is depicted in its various positions during 1 month with an adjacent image depicting on how it appears from Earth. The phases of the moon are divided by 8, and there are new moon, waxing crescent moon, first quarter half moon, waxing gibbous moon, full moon, waning gibbous moon, last quarter half moon, and last but not least, waning crescent moon. And all of these phases will be explained thoroughly throughout this presentation. So how about eclipses? What are those? Eclipses are comprises of umbra and penumbra. And umbra are the darkest shadow of an object when the sun is completely blocked in umbra, whereby penumbra are lighter shadow when the sun is only partially blocked. There are also the phenomenon of solar eclipse and lunar eclipse. Solar eclipse is when the Earth passes through the shadow of the moon, whereby lunar eclipse is when the moon passes through the shadow of the Earth. There are 3 types of eclipse that are penumbra eclipse, partial eclipse, and total eclipse. Let us start on the first phases of the moon that are new moon. What is new moon? It is when moon is almost directly between the sun and Earth, and it is the start of the cycle. It rises on 6 a.m. and the highest is at noon, and then it sets on 6 p.m. Next is waxing crescent moon. Waxing crescent moon happens when a bit of the sunlit side of the moon shows on the right side. It rises on 9 a.m. and the highest on 3 p.m. and then it sets on 9 p.m. Next is the phases of the first quarter half moon. It happens when the moon is a quarter of its way around Earth. It is in its first quarter phase. It rises on noon and the highest on 6 p.m. and then it sets on midnight. The next one will be about waxing gibbous moon. It happens when the moon is increasing in light between a first quarter moon and a full moon. It rises on 3 p.m., the highest on 9 p.m. and then it sets on 3 a.m. At the end of the 2 weeks after new moon, full moon have submerged. 2 weeks have passed since the new moon and we see the entire face of the moon shining. It rises on 6 p.m. and then on the highest is on midnight and then it sets on 6 a.m. The next one will be about waning gibbous moon. Waning gibbous moon happens when the moon is decreasing in light between a full moon and a last quarter moon. It rises on 9 p.m., highs on 3 a.m., and then it sets on 9 a.m. Next, 2 of the last phases of the moon are first, last quarter half moon, and this happens when the moon is 3/4 of its way around Earth. It is in its last quarter phase. It rises on midnight and then the highest on 9 a.m. and then it sets on noon. Next will be the last one will be waning crescent moon. It happens when a bit of the waning sunlit side of the moon shows on the left side. It rises on 3 a.m., highs on 9 a.m. and sets 3 p.m. Of all the phases, we can see that this happens in 12 hours timeline. For example, for the morning crescent moon, it rises on 3 a.m. and then it sets on 3 p.m. Next, we will be discussing about our next topic, that is eclipses. As you can see here, the before eclipses are like the normal full moon. And then for the penumbral eclipses, it happens when the moon passes through the penumbra. We can see that the moon are sitting at the penumbra, and then because of that, it was called penumbral eclipses. Next, the second types of eclipses are partial eclipse. So what are partial eclipse? It happens when parts of the moon passes through the umbra. You can see on the diagram there that the moon are either sitting on the umbra side and the penumbra side, and it causes to us to see like the partial moon. And then for the total eclipse, it happens when moon passes entirely through the umbra, and we can see on the diagram that the moon are sitting on the umbra itself. And this causes it to look like a reddish orangey moon. And that's all for me. I will be passing the batons to IRFAN Shah. Thank you.
Alright, thank you Nazihah for the explanations about moon phases and eclipse. So now I am Muhammad Irfan Shah bin ZAMRI, will continuing these presentations with the explanations about solar activity. Before we are going more further about this solar activity, let me give some definitions about what is solar activity. The Sun is a magnetic variable star that fluctuates on time scales ranging from a fractions of a second to billions of years. Solar activity is the sum of all variable and short-lived disturbances on the Sun, such as the sunspot, the solar prominence, and also the solar flares. So, in my explanations, I will share 4 examples of solar activity or sun phenomenon, which is the first one is sunspot, the second one is solar prominence, the third one is coronal mass ejection, and the last one is the solar wind. But before I go more detail about this, for example, let me give some sharing about the features of the sun. So as you guys can see, there are 3 main parts to the sun interior. The first one is the core, the second one is the radiative zone, and the third one is the convective zone. So the core one is at the center. It is the hottest region where the nuclear fusion reactions that power the sun occur. The second one is the radiative or radiation zone. This zone name is derived from the way of the energy is carried upward through this layer. This energy is carried by photons as thermal radiations. And the third zone is convective or convection zone. This zone also named after the dominant mode of energy flow in this layer. Like heat move outward via rolling convections, much like the bubbling motions in a pot of boiling oatmeal. Okay, let's start with the first sun phenomenon or the solar activity. The first one is the sunspot. Sunspots are the phenomena on the sun's photosphere that appear as temporary spots that are darker than the surrounding areas. Sunspots are regions of reduced surface temperature caused by the concentrations of magnetic flux that inhibit convection. These are some questions that relate with the sunspot, which can give more detail about what is the sunspot. So the first question is, are sunspots hot or cold? The sunspots appear in a dark color because they are cooler than the other parts of the sun's surface. But the temperature of the sunspot is still very hot because it's around 6,500 degrees Fahrenheit. The second question is, do sunspots make Earth warmer or cooler? This means that more sunspots deliver more energy to the atmosphere, so that the global temperature should rise. According to current theory, sunspots occur in pairs as magnetic disturbances in the convective plasma near the sun's surface. And the last question is, how long does a sunspot last? Sunspot can change continuously and may last for only a few hours to days, or even a month for the more intense groups. The total number of sunspots has long been known to vary with an approximately 11-year repetition known as the solar cycle. The second sun phenomenon or solar activity is the solar prominence. Solar prominence, also known as a filament when viewed against the solar disk, is a large, bright feature extending outward from the sun's surface. Prominence are encoded to the sun's surface in the photosphere and extend outwards into the sun-hot outer atmosphere called the corona. These are some questions that relate with the solar prominence, which can give more detailed explanations about what is solar prominence. The first question is, what causes solar prominence? Solar prominence, dense cloud of incandescent ionized gas projecting from the sun chromosphere into the corona. Prominence sometimes extend hundreds of thousands kilometers above the sun chromosphere. Their causes are uncertain but probably involve magnetic forces. The second question is, what happens on Earth during a solar prominence? If a prominence breaks apart, it produces a coronal mass ejection. The solar flare aspect of a prominence has the most common effect on the Earth. Normally, the magnetic field surrounding Earth deflects harmful solar radiation. The next question is, how long do prominence last? Prominence form over time scale of about a day and may persist in the corona for several weeks or months, looping hundreds of thousand kilometers into space. And some prominence may give rise to coronal mass ejections. The next question is, how hot is a solar prominence? The answer is, the temperature of prominence is 5,000 to 50,000 K. The next question is, how big is a solar prominence? According to Chison and Macmillan, the size of a typical solar prominence is on the order of 100,000 km or around 10 times the diameter of Earth. The larger ones can reach 500,000 kilometers. Prominence can show surges in timescales of hours, but the quiescent ones can persist for days or weeks. And the last question is, can we see prominence? The answer is, anyone can see prominence any day with the aid of telescope fitted with a hydrogen alpha filter. This special filter blocks all light from the sun except for the red light emitted by the excited hydrogen atoms at wavelengths of 556.3 nanometers. The third sun phenomenon or solar activity is the coronal mass ejections or CME. Coronal mass ejections are large expulsions of plasma and magnetic field from the sun's corona. They can eject billions of tons of coronal material and carry an embedded magnetic field, frozen in flux, that is stronger than the background solar wind interplanetary magnetic field IMF strength. These are some questions that relate with the coronal mass ejection, which can give more detailed explanations about what is the coronal mass ejection. The first question is, what will happen if a coronal mass ejection hit Earth? When the ejection is directed towards the Earth and reach it as an interplanetary CME, the shock wave of traveling mass causes a geomagnetic storm that may disrupt Earth's magnetosphere, compressing it on the day side and extending the night sides of the magnetic tail. The second question is, can a coronal mass ejection destroy the Earth? To be honest, it is still not enough to kill on the planet, but it is capable of destroying all the satellites around the Earth, knock out power grids and all forms of communications, even the internet. And the last question is, how long does it take for a coronal mass ejection to reach the Earth? The answer is around 1 to 3 days. The last sun phenomenon or solar activity is the solar wind. The solar wind is a stream of charged particles released from the upper atmosphere of the sun called the corona. This plasma mostly consists of electrons, protons, and alpha particles with kinetic energy between 0.5 and 10 keV. these are some questions that relate with the solar wind, which can give more detailed explanations about what is solar wind. The first question is, what happens if solar wind hits Earth? The answer is standing wave. According to experts, when solar wind passes contact the magnetosphere, waves form that rush back and forth along Earth's field lines. The next question is, how does solar wind affect humans? Solar storms emit radiations. This exposure can give harmful to humans and can cause organ damage, radiation sickness, and cancer. But most experts state that there is no significant risk to humans on the ground from solar flare. And the last question is, what protects us from solar wind? Earth's magnetic field serves to deflect most of the solar wind, whose charged particle would otherwise strip away the ozone layer that protects the Earth from harmful ultraviolet radiations. So, this Earth's magnetic field is the things that protect us from the solar wind. As a conclusion, why we need to learn and understanding this astronomical phenomenon, because first it gives us a source of inspirations and can improve people's everyday life. The universe is infinity and we are of but the tiniest fractions of importance. This life is rare and precious. A home as beautiful and unique as Earth does not come often. We must protect it. The sky and its stars have inspired art, music, and religion throughout the history of mankind. It is no secret that the beauty and the mystery of the universe are a source of inspirations for many people. No matter what your motivations, whether it comes from artistic wonder or a wish to understand humanity better, astronomy has the power to change your perspective on everyday life. Not just that, when we learn about this thing, we can learn more and appreciate all the creations of Allah. In Surah Al-Qamar verse 49, thus everything in the universe has been created beautiful with purpose and in proportions and measure both qualitatively and quantitatively. I think that's all from me from group 2. I hope you guys get some benefit from these presentations and please share all this knowledge to the people outside. I think that's all from us. Till we meet again, Assalamualaikum and thank you.